This is the EdExcel GCSE 9-1 Maths Paper 3, which is a calculator paper. It's from the higher tier and it's from the June 2017 series. For question number 1, we have a set of numbers which are odd numbers less than 30. The set A has numbers 3, 9, 15, 21 and 27. The set B has numbers 5, 15 and 25. For part A, we have to complete the Venn diagram to represent this information. Well, first of all, you will find the 15 to be common to both. So we have 15 over here. And what goes in A only then, we have the 3, we have the 9, we have the 21, and we have the 27. And for B only, we've got 5 and 25. Now, what goes outside of the circles here are the numbers which are less than 30, but's not included in A and not included in B. So you'd find those numbers to be 1, 7, 11, 13, 17, 19, 23, and 29. So this is our completed Venn diagram. And now for part B, a number is chosen at random from the universal set. What is the probability that the number is in set A or B? Well, first of all, you'll recognize that we have 15 odd numbers which are less than 30. So our probability will be out of 15, and of those 15, the ones that belong in A or B, well, we've got 1, 2, 3, 4, 5, 6, and then the 7. So the probability is equal to 7 over 15. Question number 2, we have to solve the simultaneous equations 3x plus y equals minus 4, 3x minus 4y equals 6. Well, if I call this equation 1 and the second one equation 2, first of all, you will notice the number in front of the x, in other words, the coefficient of x, is the same. And because of that, we can subtract the equations. So we will do equation 1, take away equation 2. And if we do that, 3x take away 3x, that is 0x. Y take away minus 4y, that's the same as y plus 4y, which is 5y. And minus 4 take away 6, that is minus 10. So therefore, we have 5y equals minus 10, and from this we can find out what y is. So if we divide through by 5, you will find y to equal minus 2, because minus 10 divided by 5 is minus 2. We can now use this value of y equals minus 2 and substitute this into either equation to find out what the corresponding value of x is. So, if I sub into equation 1, we have 3x plus y, which I've just said is minus 2, and this is equal to minus 4. So I've got 3x minus 2 equals minus 4. If I add 2 to both sides, 3x is equal to minus 2 because minus 4 plus 2 is equal to minus 2. And if I divide through by 3, you will find x to equal minus 2 over 3. So we have a solution, x equals minus 2 over 3 and y equals minus 2. Question number 3. The table shows some information about the dress sizes of 25 women. So we've got the dress size here and the number of women who have that particular dress size. For part A, we have to find the median dress size. Well, we have 25 women in total, so we can find the position where the median lies. Of course, we would have to do 25 plus 1 divided by 2. It turns out we get 13, so the 13th value would correspond to the median. Now the next question is, what is the 13th value? Well, if we create a cumulative frequency column, we begin with the 2, 2 plus 9, that's 11, 11 plus 8, that's 19, 19 plus 6, that's 25. So you can see that the 13th value will lie over here, which corresponds to a dress size of 12. Now for part B, 3 of the 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because 3 over 25 plus 6 over 25 equals 9 over 25. Is Zoe correct? Well, if we take a look over here, so the 3 over 25 over here, this represents those women who have a shoe size of 7. So here we have shoe size of 7, as we see here. And the 6 over 25, well, if we go back, there's 6 women out of the 25 who have a dress size of 14. So this value here would represent the dress size, and of course there are 6 women with a dress size of 14. So the reason why she is incorrect, well, what she's done over here is added the probabilities, and you can't do that because the events are not mutually exclusive. In other words, we can have a shoe size of 7 and we can have a dress size of 14. In other words, a person could belong in both categories. So let's just write down that reason. So the events are not mutually exclusive. In other words, a person can have a dress size of 14 and a shoe size of 7. Question number 4. Daniel bakes 420 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes and chocolate cakes. 2/7 of the cakes are vanilla cakes. 35% of the cakes are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 4:5. We have to work out the number of lemon cakes Daniel bakes. Well, let's take this a statement at a time. Let's first of all take a look at vanilla cakes. If we take a look at the vanilla cakes, 2/7 of the total amount of cakes are vanilla, so we need to work out 2/7 of 420. So if we work this out, then here we've got 2 over 7 multiplied by 420, which is equal to 120. So we have 120 vanilla cakes. And if we take a look at banana cakes, we've got 35% of the total amount of cakes being banana cakes. So we need to work out 35% of 420. So we've got 35% multiplied by 420. It turns out we get 147 banana cakes. So the number of vanilla cakes we have is 120. The number of banana cakes we have is 147. With this, we can find out the number of lemon and chocolate cakes. So the total number of lemon cakes and chocolate cakes, well, we've got 420, the total amount of cakes. Take away the number of vanilla cakes, which is 120. Take away the number of banana cakes, which is 147. So it turns out we get 153. So we have 153 lemon and chocolate cakes. Now we know already the ratio of lemon to chocolate is equal to 4 to 5. We already know that there's 153 lemon and chocolate cakes in total, so with this ratio we can find out the number of lemon cakes we have. Well, 4 plus 5, that's 9. So we've got 4 plus 5, which is equal to 9, so we have 9 parts. And therefore, 153 divided by 9, that's equal to 17. We have 17 per part. So, the number of lemon cakes, we can find that out by multiplying 4 by 17. So therefore, the total number of lemon cakes we have is 4, because we have 4 parts, multiplied by 17. It turns out here we get 68 lemon cakes in total. So we have 68 lemon cakes. Question number 5. In the diagram, AB, BC and CD are 3 sides of a regular polygon. So we have a square here, we've got another square here, here we've got a regular 12-sided polygon, and here we have a polygon P. And in this question we have to show that polygon P is a hexagon showing all our working. Well, for regular polygons, the exterior angle is equal to 360 divided by the number of sides n, and therefore the number of sides is equal to 360 divided by the exterior angle. The interior angle is equal to 180 minus the exterior angle, and therefore the exterior angle is also equal to 180 minus the interior angle. So we will use these information to help us determine, to find out the number of sides polygon P has, and if we get 6, of course, we can conclude that P is a hexagon. Well, first of all, we can find the exterior angle of the square. The exterior angle of the square is equal to 360 divided by the number of sides we have, which is 4. So of course the exterior angle of the square is 90 degrees. So let's try to show this. Here we've got 90 degrees for the exterior angle of the square, and we can continue this over here. Here we've got 90 degrees for the exterior angle of the square, and we can also show the same thing over here. Now we can also find the exterior angle of the 12-sided shape. The exterior angle of the 12-sided shape, that's equal to 360 divided by 12, which is 30. So we have 30 degrees for the exterior angle. So if I attempt to show this, here we've got 30 degrees. Here we have also 30 degrees. Now, what we can do is find the interior angle of shape P, which will be this angle over here, which of course corresponds to this angle here, the angle ABC. So, the interior angle of shape P, that will equal, well, here we've got the 90 degrees plus the 30 degrees. It turns out the interior angle of shape P is equal to 120 degrees. So we have 120 degrees here. And therefore we can use this over here to find the exterior angle of shape P. The exterior angle of shape P is equal to 180 minus the 120, which is the interior angle. So it turns out here we get 60 degrees. So what does this mean? Well, it means here, if I extend this line further, this angle over here is 60 degrees. Okay? And therefore, we can use this formula to help find the number of sides. So therefore, the number of sides n for shape P is equal to 360 divided by the exterior angle of shape P, which is 60. It turns out we get 6. And therefore, shape P is a hexagon. Question number 6. The density of apple juice is 1.05 grams per centimeters cubed. The density of fruit syrup is 1.4 grams per centimeters cubed. The density of carbonated water is 0.99 grams per centimeters cubed. 25 centimeters cubed of apple juice are mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with a volume of 320 centimeters cubed. You have to work out the density of the drink, give your answer correct to 2 decimal places. Here is the formula triangle linking density, mass and volume. Now if we consider apple juice, we've been given the density and we've also been given the volume. So with this we can find the mass of apple juice, and we can do a similar thing with the fruit and the water. So if we consider the apple, we've got 1.05 grams per centimeters cubed. So we've got 1.05 grams per centimeters cubed for the density, and We multiply this by 25 centimeters cubed, which is the volume. So if we work this out, you will find we use our calculator, 1.05 times 25, which is 26.25. So we have 26.25 grams for the apple juice. For the fruit syrup, we have the density being 1.4 grams per centimeters cubed multiplied by the 15 centimeters cubed. So if we work this out, it turns out we get 21 grams. And if we consider the carbonated water, we have the density being 0.99 grams per centimeters cubed. We have the volume being 280 centimeters cubed. So if we work this out, we get 0.99 times 280, which is 277.2 grams per centimeter, 277 grams. Now, we were told that the total volume is 320. So we have the total volume being 320 centimeters cubed. We can add these together to find the total mass. So the total mass is equal to 26.25 plus 21 plus 277.2. So the total mass is 324.45 grams. And therefore, for the total density, the density we've got the total mass over the total volume. So we've got the total mass being 324.45 grams. The total volume, we've got 320 grams, we've got 320 centimeters cubed. So if we work out the total density to 2 decimal places, we've got 324.45 divided by 320, which is equal to 1.01. So we have 1.01 grams per centimeters cubed to 2 decimal places. So we have 1.01 grams per centimeters cubed to 2 decimal places. Question 7. ABC is a right-angled triangle. We've got AC being 15 centimeters, the angle ACB being 23 degrees, and we have to calculate the length of AB, giving our answer correct to 3 significant figures. Well, AB over here, because it's opposite the angle, would represent the opposite. The 15, which is the longest side, directly opposite the right angle, is the hypotenuse. We are finding the opposite. We've been given an angle, we've been given the hypotenuse. What connects the opposite to the hypotenuse is sine. So we have sine of 23 equals opposite, which is what we're finding, AB, over the hypotenuse, which is 15. We need to find out what AB is. So AB is equal to 15 times by the sine of 23. So we have 15 times by the sine of 23, which is 5.86 centimeters to 3 significant figures. So therefore, AB is equal to 5.86 centimeters to 3 significant figures. Question number 8. A square with sides of length x centimeters is inside a circle. Each vertex of the square is on the circumference of the circle. The area of the circle is 49 centimeters squared, and we have to work out the value of x, giving our answer to 3 significant figures. So here we have a square and a circle, and each vertex on the square touches the circumference of the circle. And we know that the square has length x centimeters, so we have x over here, 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 and also here. Now, we need to find out the value of x, and we've been given the area. The area is 49 centimeters squared. Now let's think about how we work out the area of a circle. The area of a circle is given by pi r squared. So we know the area to be 49 centimeters squared. And, well, let's think about how we can find the radius. Well, here in red we've got the radius, and from this, if we form a right-angled triangle, well, we've got one side here and we have another side here. Okay, so we've got this length being x over 2 because we're going from the center point of the circle, which corresponds to half the length of the square. So here we've got x over 2, and here we've also got x over 2 because we have a square. So we can find out the radius in terms of x, and from that we can find out what x is. So if I draw out this triangle once again, we've got the length here, which is x over 2. We've got the other length here, which is x over 2. And we've got r connecting them together. So we need to find out what r is. We can of course use Pythagoras. Through Pythagoras, okay, so through Pythagoras, we've got x over 2 all squared plus x over 2 all squared. This is equal to r squared. So we have x squared over 4 plus another x squared over 4. Well, that will be x squared over 2. So x squared over 2 is equal to r squared. So now if we substitute this into here, we've got pi lots of x squared over 2. So this is what r squared is. And that's what we worked out here. So here is r squared. So if we multiply by 2 and then divide by pi, what we have over here then is x squared equaling 2 times by 49 divided by pi. So from this we can find out what x is. X is equal to 2 times by 49 over pi square rooted. So if we work out what x is equal to the square root of 2 times by 49 over pi. So here we've got 2 times by 49 over pi, which is 5.59 to 3 significant figures. So we have 5.59 to 3 significant figures. Question number 9. The box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. And for part A, we have to work out the interquartile range for the amounts of money spent by these male students. Well, the interquartile range is equal to the upper quartile take away the lower quartile. So we've got the upper quartile, which corresponds to this value, and of course this value is 330. And for the lower quartile, we've got this value here, which corresponds to 150. So for the interquartile range, we get 180. So the interquartile range is £180. Now for part B. The table below shows information about the distribution of the amounts of money spent by some female students on their holidays. We've got the smallest value, the largest value, the median, the lower quartile, and the upper quartile, and on the grid below we have to draw a box plot for this information. So first of all, we know that the smallest value is 60, so if we find out where 60 is, we've got 60 over here. Okay? So here we've got the smallest value. Then for the largest value we've got 650. So 600 is here and 650 is halfway between 600 and 700. So here we've got 650. Okay? Then we've got the lower quartile, which is 180. So 180 is over here. The median is 300, so 300 is over here. And 350 is what we get for the upper quartile, so that's halfway between 300 and 400. So now we need to join all these up. So if we join all of these up, first of all, we've got these points here. And then we've got these points here. And then we've got these points here. And these points here. So here is our box plot. Now for part C, Chris says the box plots show that female students spent more money than male students. Is Chris correct? Give a reason for your answer. Well, if we take a look at the median for the males, that's 250, and the median for females is 300. So we've got the median for males being 250 and the median for females being 300. So what we can see, because females have a higher median, this would suggest that they spent more on average. So therefore, Chris is correct because females have a higher average than males, and this suggests that females spent more than males. Question 10. Niobe invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8029.35. We have to work out the value of X. So here we've got our original amount, that's 6,000. We then multiply this by 1 plus X over 100, this is our multiplier, and then we will raise this to the power of 5 because we are investing for 5 years, and the final amount we get is 8029.35. So, first thing we can do is divide both sides by 6,000, and if we do that, we get 1 plus X over 100 to the power of 5 equals, well, here we've got 8029.35 divided by 6,000, which is 1.33, etc. We now need to take the fifth root of both sides, and if we do that, we get 1 plus X over 100 equals the fifth root of this, which is 1.05, etc. We then need to subtract 1 from both sides. So if we subtract 1 from both sides, we end up with X over 100 equals 0.05, etc. Now if we multiply both sides by 100, you will find X to equal 5.99, etc. So therefore, to 1 decimal place, we get X equals 6.0 as our final answer. Question 11. Jeff is choosing a shrub and a rose tree for his garden. At the garden centre there are 17 different types of shrubs and some roses. Jeff says there are 215 different ways to choose one shrub and one tree. Could Jeff be correct? You must show how you get your answer. Well, there's 17 shrubs, and let X be the number of rose trees. And if we multiply those together, we should get 215, because he is saying that there are 215 different ways of choosing these combinations. So we will let X be the number of rose trees, and therefore the number of combinations, well, we've got 17 shrubs, X rose trees, so the number of combinations is 17X. And therefore, we've got 17X equals 215, because he is saying that there are 215 different ways of choosing one shrub and one rose tree. So if we find out what X is equal to 215 divided by 17, which is 12.64, etc. So what we're saying over here is that there are 12.64, etc. rose trees. And because this is not an integer, we can therefore conclude that Jeff is incorrect. Question number 12. The points A, B, C and D lie in order on a straight line. The ratio AB to BD is 1 to 5 and the ratio AC to CD is 7 to 11. We have to work out the ratio AB to BC to CD. Well, I think here it will be a good idea to draw a straight line with the points A, B, C and D. So here we've got a straight line and we've got the points A, B, C and D. Now let's first of all consider AB to BD. Well, if I just copy and paste this, okay, so we've got the same thing again, and if I just get rid of this point C, we know already AB to BD is 1 to 5. So here we get 1 to 5. And if I paste this again, here, if we take a look at AC to CD, well, here we'd have to get rid of the B. So if I get rid of the B, here you can see we've got 7 to 11. So if we recognize that the points A and D are always going to be the same, this tells us over here we've got 18 in total for AD. So here we have 18 in total. The reason we have 18, 7 plus 11 gives the 18. So you can see here we have 6 in total because 1 plus 5 is 6. So here we have 6 in total. So we can multiply by 3, and if we do that, we've got 3 to 5 times by 3, which is 15. So what does this mean? Well, it means here that we've now got everything sort of the same. So AB is 3 parts, A to C is 7 parts, and CD is 11 parts, and now the total of A to D gives 18. So now multiplying by 3 gives AD being 18 for this over here. So we see that AB, this is equal to 3, as we see here. We see that B to C, well, we need to work that out. BC, that will equal AC take away AB. So here we've got 7 take away 3, which is 4. And we've got CD equaling 11. So if I add everything to the diagram, here we've got 3 for AB. We've got BC being 4 and CD being 11. And of course, adding these together gives the 18, which is the total length of AB, of AD rather. So the ratio is equal to as we see from here, 3 to 4 to 11. Question 13. We have to write down 3 inequalities that define the shaded region. So for us to do that, well, what we need to do is find out the equations of each of these lines, and from that we can write down the corresponding inequalities. Well, what we should know already is a straight line is of the form y equals mx plus c, where m would represent the gradient and c would represent the y-intercept. So if we take a look at this line over here, and perhaps what I can do as well is draw over it. This line here is the line y equals 2. This line over here, if I draw over it, well, it goes through the origin. It has a gradient of 1, so this line here is y equals x. And if we take a look at this line over here, we've got a gradient of 1/2 because we go 2 across and 1 up. So we've got y equals 1/2 x, and then it crosses the y-axis at the point 1. So this line here has equation y equals 1/2 x plus 1. Now, when we come to define our inequalities, well, first of all, the region we want is shaded. So we want, if I consider what's going on here, I want everything above this line here. So I want everything above that line. Okay. So I want everywhere where y is greater or equal to 2. So far we've got y being greater or equal rather than -2. So let's just correct this here, we should have -2. And if I consider everything above this point, which is what I want, then I want everything where y is greater than x. So here we've got y being greater or equal to x. And then we want everything below this line here. So if we show that, then just show it properly. Then here we've got y being less than or equal to 1/2 x plus 1. Question 14, part A, we have to simplify x squared minus 16 over 2x squared minus 5x minus 12. First of all, let's consider the x squared minus 16. You'd find here we have a difference of 2 squares. We can rewrite this as x plus 4 lots of x minus 4. And if we now consider the 2x squared minus 5x minus 12, well, here I need two numbers which multiply to give the 2 times minus 12, which is minus 24, and which add to give the minus 5. You'd find those two numbers to be minus 8. and 3. So we can rewrite this minus 5x term in terms of what we've just found. So we have 2x squared minus 8x plus 3x minus 12. And if we split this down the middle, we can factorize the left bit as 2x lots of x minus 4. I want an x minus 4 here as well, and 3 lots of x minus 4 gives 3x minus 12. So when I combine these together, we can therefore conclude that 2x squared minus 5x minus 12 is the same as, grouping these terms, 2x plus 3 lots of x minus 4. So therefore, when we come to simplify this expression, if we use our factorized form of these quadratics, well, on the bottom, we've got 2x plus 3 lots of x minus 4, and on the top, we've got x plus 4 lots of x minus 4. And noticing that the x plus 4 and the x minus 4 cancel on the top and bottom, you will find we get x plus 4 over 2x plus 3 as our final answer. So this is our final answer. Now for part B, we have to make v the subject of the formula w equals 15 lots of t minus 2v over v. First thing we can do is multiply both sides by v. And if I do that, the v here cancels with the v here, leaving me with vw equals 15 lots of t minus 2v. If we expand the brackets on the right hand side, we have vw on the left hand side and 15t minus 30v on the right hand side. Now if we take everything over to one side involving a v, of course here we need to add 30v to both sides. So we get vw plus 30v equals 15t minus 30v. So if we factorize on the left hand side, we have v lots of w plus 30, rather here we just have we have over here on the right hand side 15t. So if we now divide both sides by w plus 30, you will find that v is equal to 15t over w plus 30. So we have v equals 15t over w plus 30. Question 15. We have a triangle ABC over here. AB is 2x minus 1 meters, BC is x plus 3 meters, and the angle ABC is 45 degrees. The area of the triangle ABC is 6 root 2 meters squared. We have to calculate the value of x. Well, here we should know that the area of a triangle is equal to 1/2 times by AC times by the sine of B. So here we've got the length A, here we've got the length C, and here we've got the angle B. So, using that information, we have 1/2 times by a, which is x plus 3, times by 2x minus 1, times by the sine of 45. This is all equal to 6 root 2. So if we tidy everything up, we've got 1/2 lots of x plus 3 lots of 2x minus 1 lots of, well, sine 45 is root 2 over 2. And all of this is equal to 6 root 2. Now, happily for us, the root 2's cancel on both sides. And if I multiply through by 4, then on the left hand side we get x plus 3 lots of 2x minus 1 equals 6 times by 4, which is 24. And now if we expand the brackets on the left hand side, we get 2x squared plus 5x minus 3 equals 24. And if we subtract 24 from both sides, we will find 2x squared plus 5x minus 27 is equal to 0. So to find out what x is, we can use the quadratic formula. Let's just remind ourselves of what the quadratic formula is. Here we've got the quadratic formula. So to find out what x is, we simply substitute all the values into the quadratic formula. So we've got minus b, so we've got minus 5 plus minus b squared, so here we've got 5 squared minus 4ac divided by 2 times by 2. Then of course here we've got the square root. So if we work out what x is, of course we can substitute this into our calculator, but for those of us who own the Casio ClassWiz, substitute everything in as we see here. So we've got 2x squared plus 5x minus 27. So we get two values. The decimal equivalent, we've got 2.63, etc. And we've also got minus 5.13, etc. Now, because x is greater than 0, because we have length, we need to reject the negative. So we will reject this value here, leaving us with x equals 2.63 as our only solution. So x equals 2.63 to 3 significant figures. Question 16. Using xn plus 1 equals minus 2 minus 4 over xn squared, with x0 equaling minus 2.5, we have to find the values of x1, x2 and x3. So we will begin with x0 equaling minus 2.5. x1 is equal to minus 2 minus 4 over x0 squared. So here we've got minus 2 minus 4 over minus 2.5 squared. So if we work this out, well, first of all we substitute in the minus 2.5 into the answer function, and then we've got minus 2 minus 4 over answer squared. So here we get minus 2.64. x2 is equal to minus 2 minus 4 over x1 all squared. So we've got minus 2 minus 4 over minus 2.64 all squared. So if we work this out, press answer again, it turns out here we get minus 2.573921.028. And x3, that's equal to minus 2 minus 4 over x2 squared. So we've got minus 2 minus 4 over minus 2.57 etc. squared. So working this out, we get minus 2.603767.255. So now that we've got all our values for x1 and x2 and x3, we can simply just copy these down. So here are our values of x1, x2 and x3. Now for part B, we have to explain the relationship between the values of x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0. Well, if we take a look at this equation here, we can rearrange this equation to get something similar looking to this equation. So if we do that, we can start off with the x cubed plus 2x squared plus 4 equaling 0. And if we rearrange by subtracting 2x squared minus 4 from both sides, we end up with x cubed equaling minus 2x squared minus 4, from which we can conclude x is equal to, well, if we divide through by x cubed, we have minus 4, or rather here we've got minus 2x squared divided by x cubed. Rather here, if we just divide through by x squared, actually, we get x equals minus 2 minus 4 over x squared, which is similar to the iterative formula as we see here. So the original formula that's over here we should be saying the original equation. This is rearranged to give the iterative formula as we see here. So this is the iterative formula. Okay? So that's where the iterative formula comes from. So in terms of how these relate to the values of x1, x2 and x3, so the values of x1, x2 and x3 are estimates to the roots of the original equation over here. Question 17. A train travelled along a track in 110 minutes, correct to the nearest 5 minutes. And Jake finds out the track is 270 kilometers long. He assumes that the track has been measured, correct to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? You must show how you get your answer. Well, here, the time has been measured to the nearest 5 minutes. So, from this we can find the upper bound and the lower bound of the time. So the upper bound of the time, that's equal to 112.5 minutes, and the lower bound of the time, that's equal to 107.5 minutes. We can also do a similar thing with the distance. The upper bound of the distance is equal to, well, if we're measuring to the nearest 10 kilometers, the upper bound here will be 275 kilometers, and the lower bound of the distance, this will equal 265 kilometers. Now, you'd first of all notice we've got a time and we've got a distance, and we're considering average speeds. The formula collecting them, of course, speed is equal to distance over time. Now, you'd first of all notice as well, we've got here kilometers per hour, but here the time's given in minutes. So we need to convert between minutes and hours. So, to go from minutes to hours, we would have to divide by 60, and to go from hours to minutes, we would have to multiply by 60. So let's bear that in mind. We'll use it later on. So when we consider the average speed, well, here, let's consider the greatest speed at which we're traveling at. And the reason I'm considering the greatest speed is because here we're thinking about whether the speed of the train could have been greater than 160 kilometers per hour. So the greatest speed, well, if I consider bounds, I've got the upper bound of the distance divided by the lower bound of time. So upper bound of distance, that's 275 kilometers, and the lower bound of time, that's 107.5 divided by 60. Let's just show this in red actually. Hours. So I've got 275 divided by 107.5 over 60, which is 153.4 etc. kilometers per hour. And because this is less than 160 kilometers per hour, we can therefore conclude no. Now for part B, Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometers. We have to explain how this could affect your decision in part A. Well, if we now consider the upper bound of the distance, the upper bound of the distance, if we're measuring to the nearest 5 kilometers, this will equal 272.5 kilometers. And if we compare that with what we had before, well, here we've got 275 kilometers, now we've got 272.5 kilometers, and if I divide this by 107.5 over 60, you can see we get a less speed. So how can we put this into words? So less distance covered in the same time would mean that the average speed would be lower. Question number 18. A, B and C are points on a circle of radius 5 with centre O. DA and DC are tangents to the circle. And because they're tangents, this length will equal this length because tangents from a point are equal. So let's just write that down. Because tangents from a point are equal, we can therefore conclude that AD equals CD. And because of that, we can also conclude that the triangle AOD, let's just show this in black. We can therefore conclude from here then that the triangle AOD equals the triangle OCD. Now, for me to work out the arc, I need the angle AOC. So somehow I need to find out the angle AOC. And I know that DO is 9 centimeters, and if that's the case, then, if DO is 9 centimeters, then that means this length here is 9 centimeters. So here, we've got 9 centimeters for DO. So what we'll do is we'll draw out the triangle AOD, and of course what you'd recognize about this triangle is because the tangent and the radius are perpendicular to each other, the angle A here and the angle C here is equal to 90 degrees. So let's just draw out a quick triangle. Well, here I've got this triangle and I've got this side, which is 5. This is 9. Here I've got 90 degrees. So I can find out what this angle here is. Now, if we label our sides, I want this angle over here. And this angle is also equal to this angle. So if I work out what this angle is, then of course here we've got the adjacent, here we've got the hypotenuse. What connects those is cosine. So the cosine of the angle AOD is equal to the adjacent 5 over 9, which is the hypotenuse. So therefore the angle AOD, that's equal to the inverse cosine of 5/9, which is 56.25, etc. So we have 56.25, etc. degrees. So this angle is 56.25, etc. So if I add this to the diagram, we've got 56.25, and here we've got 56.25, etc. So therefore the angle AOC that's equal to 2 lots of 56.25. Let's just show this in red. So if I multiply this by 2, that's equal to 112.50, etc. Now, we should know that angles around a point sum to 360. So therefore, if we recognize that here we've got the minor angle, then AOC major is equal to 360 minus 112.50, etc. So 360 minus this is 247.49. So we've got 247.49, etc. So that means that this angle here is 247.49, etc. Okay, so let's just rub this out a bit. So this is this angle here. Well, how does that help us? Because what we can now do is find out the arc length of ABC. This length here is what we need to figure out. So the arc length, if we write out the formula for that, the arc length here is equal to theta, the angle we've just found, over 360 times 2 pi r. So we've got A, B, C, the arc length, equals 247.49, etc. over 360 multiplied by 2 pi multiplied by 5, which is the radius. So if we find out what ABC is, we've got this value, divide 360 times by 10 pi, because we've got 2 times by 5. So here we get 21.598, etc. So therefore, to three significant figures, we've got 21.6 centimeters. Question 19, we have to solve the inequality 2x squared plus 3x minus 2 being greater than 0. Well, first thing we will do is replace the inequality sign with an equal sign to help find the critical values. So we've got 2x squared plus 3x minus 2 equals 0. And now if we attempt to solve this, well, I need two numbers which multiply to give 2 times minus 2, which is minus 4, and which add to give the 3. You'd find these two numbers to be 4 and minus 1. So I can rewrite the 3x in terms of what I've just found. So we've got 2x squared plus 4x minus x minus 2 equaling 0. And if I split this down the middle, factorising the left bit, we've got 2x lots of x plus 2. I want an x plus 2 here as well, and obviously equals 0. And you'd find minus 1 times by x plus 2 gives minus x minus 2. And grouping the terms together, we've got 2x minus 1 lots of x plus 2 equaling 0. So from here, you can see that 2x minus 1 is equal to 0, or from here, x plus 2 equals 0. And solving, you will find x to equal either 1/2 or minus 2. So therefore, these are our critical values. Our critical values are 1/2 and minus 2. So now if we sketch the graph, let's draw on a quick set of axes. Something like this will do. And we've got 1/2 and minus 2. So our graph looks like this. It crosses at 1/2. It also crosses at minus 2. We've got x and y. And we want where the graph is greater than 0. And it's greater than 0 here and also here. So we've got two solutions. We've got the solution x being less than minus 2 and x being greater than 1/2. Question 20. The equation of a curve is y equals a to the x. A is the point where the curve intersects the y-axis, and we have to state the coordinates of a. Well, if I draw the graph of a to the x, here I've got my x-axis, here I've got my y-axis. The graph looks something like this. We have y equals a to the x. It crosses the y-axis at the point A. That will be 0, 1. Or the coordinates are 0, 1, because when x equals 0, y is equal to a to the power of 0, which is 1. So it crosses at the point 0, 1. Now for part B, the equation of the circle C is x squared plus y squared equals 16. The circle C is translated by the vector 3, 0 to give circle B. We have to draw a sketch of circle B. We have to label with coordinates the centre of circle B and any points of intersection with the x-axis. So, first of all, what you will find is if I rewrite the equation of C as x squared plus y squared equals 4 squared, obviously 4 squared equals 16, you can see here that the radius is equal to 4. Now this circle is translated by the vector 3, 0 to give circle B. So what we have here is circle C, and for circle B, if we translate this by this vector, we've got x minus 3 all squared plus y squared equals 4 squared. So this is the equation of the circle as a result of translating by vector 3, 0. So that's why we've got the minus 3 over here. So this is the equation of circle B. What we now need to do is find out where it intercepts with the x-axis, and we can do that by setting y equal to 0. So when y equals 0, we've got x minus 3 all squared equals 4 squared, and square rooting, we've got x minus 3 equals plus minus 4. So x is equal to 3 plus minus 4. In other words, x is equal to minus 1 and 7, because 3 plus 4 is 7, 3 minus 4 is minus 1. Now from here we can conclude that the centre of the circle has coordinates 3, 0. And from here we can conclude that the x-intercepts have coordinates minus 1, 0 and 7, 0. So now let's draw the graph. Well, here we've got a set of axes, and let's show the point. Well, the radius is 4, and we've got the centre. So centre is 3, 0. So here is the centre, and the radius is 4. So we've got here one of the points, which is minus 1, 0, and the other point is here. So now we need a circle connecting those. So if we show the circle, here is our circle, okay? And in terms of the coordinates, well, here we've got minus 1, 0, that's here, and here we've got the coordinates 7, 0, and here we've got the coordinates 3, 0. So we've got the x and y axis. This is our circle.